Good morning. Today is lesson 45, which is parentheses and the associative property part 1. We have got a lot to cover, so I hope you have your math journal out and that you can take notes along with me. Our first thing is we need to talk about some vocabulary. We know, we're going to write down this word parentheses. And parentheses are grouping symbols that indicate where to begin when simplifying an expression. So you work in the parentheses first, where to begin. And that leads to when knowing how to proceed on a problem, there is what we call an order of operations. And in our order of operations, we begin with parentheses. We work with the things in the parentheses first. A set of rules for the order in which to begin, in which to solve math problems. Now, even with that said, there is one property that it doesn't really matter how things are grouped, and that is the associative property of addition. You write this down too. And the associative property of addition, oh man, this is a lot, is that the grouping of addends, remember those, the numbers that we add up, addends does not affect their sum. And here we have an example of just some variables. A plus B plus C is the same as if you put it in parentheses A plus B plus C. So it's really nice to know when you're working with addition, sum, that you can organize that in a way and know that it's not going to be affected by where you put parentheses. Now, addition and multiplication kind of relate to each other because we also have the associative property of multiplication. And it is very similar. Ooh, guys, I hope we'll have to off-road that. Is that the grouping of factors does not affect their product. Does not affect their product. So if you have A times B times C, you can put it in different parentheses, but you will still get the same number. And that's really handy. So let's do a few of these together. 3 plus 4 plus 5, 3 plus 4 plus 5. Now we know right offhand that this is the associative property, that they're showing us an example of the associative property of addition. So we know automatically that this is going to be the same on both sides. But I want you to work through it and let's see if this really does work. So we work with our, we do our parentheses first. So 3 plus, so we say 3 plus 9. And we also are going to do our parentheses here, 7 plus 5. And let's continue down adding this. 3 plus 9 is 12. 7 plus 5 is 12. So we know that these are equal. Here's an example of the associative property in work with multiplication. Let's try this. 3 times, we know that 2 times 5 is 10, and 3 times 6 times, now I'm 6 times 5 is 10, so let's do these. 30 and 6 times 5 is 30, so we know, ta-da, they are equal. Now we need to talk about, once we're moving on from the associative property of multiplication and addition, I need to throw in a few little things regarding geometry and regarding shapes. First off, we can talk about lines all day long, but you can indicate a line by creating a point and a point, and we put them together, and to show that they keep going, we can move them out between our points, and this is an example of a line. We'll label this A and we'll label this B, and that line will go on forever. If we want to show that it is a line, we can, this is how we indicate it. Now, segments are different. Here is a line segment. It goes from a point to a point, and it stops. And we can have different line segments within the line. We can say here is A and B, and we can say AB is a line, or BA is a line segment. We also need to talk a little bit about which segments of this triangle are perpendicular. When we say perpendicular, it means that it is a 90-degree angle. And here we have 3 angles, right here, this one, and then this one. And you can see that this is which segments of this triangle are perpendicular. So we need to look at our segments of P and R, and then our segment of R and Q. And because these are our segments through here. Now they want us to work with naming a pair of segments that appear to be parallel to line AB. By the way, I'm not liking this up here, because if we wanted to write a line, we would write it like this, BA or AB. That would be an indication of line. For a segment, I messed up here. It would just be the 2 letters. So remember that, okay? Next part, name the pair of segments that appear to be parallel to line AB. Now, parallel means that it's exactly the same distance between 2 lines. They never intersect. And so we see that we've got some lines going like this. We have some parallel lines going here. They want to know, name the pair of segments that appear to be parallel to line AB. So this is the AB. I can see right now that DC is parallel, or we can say CD. I'm going to erase this. DC is parallel. Or we also have this line that appears to be parallel of EF. So DC or EF. And we could also say CD or FE. But for all intents and purposes, you can see that this is running parallel, and you can see that this is also running parallel because it is a rectangle. Our next one, the length of line AB is 3 centimeters. The the length of BC is 4 centimeters. So we have BC. Saxon loves this kind of problem. You will see it in your tests from time to time. Sometimes they'll give you the whole measurement and then they'll say, what is the measurement of BC? In this situation, they want to know the whole measurement of here. I just look and I say, I've got 3 centimeters, and then I look and I have 4 centimeters, and I know that my whole, that AC equals 7 centimeters. Please note that they love to throw that in tests, so get really comfortable. We're going to pause now, and I wish you well.